The transponder then sends its signal with information to identify the aircraft back to the secondary antenna. A third unit of air traffic control housed in this building, several miles from the aerodrome, is Miami Air Traffic Control Center. The center handles traffic around and above the approach control zone. The main difference between approach control and this area control center is the extent of coverage. To this building, radar is beamed from such remote long-range radar sites as we have here. A radar antenna similar but larger than the one we saw rotates within this radome, the range of this equipment being somewhat more than 200 miles. The signal from this and other similar sites is beamed via microwave repeater stations to the control center, often hundreds of miles away. Then down the mast into this parabolic antenna through microwave channeling into the area control center. From this control room, day and night, 7 days a week, 225 highly trained and skilled air traffic controllers, along with 49 expert radio and radar technicians, provide safe separation for aircraft flying along some of the world's most heavily traveled airways. As with all things, the numbers of present air traffic will seem small to controllers looking back in years to come. But today, the service is continually under pressure to keep pace with the explosive growth of aviation. And so we have seen the tower, which controls aircraft on the ground and in the immediate vicinity of the aerodrome. We saw approach control, which handles traffic arriving or departing from an aerodrome. And the last unit we have just seen was area control. However, let's start again with aerodrome control. This time we will examine the parts in greater depth. Standing at the left is the cab coordinator, who supervises and coordinates activities. He also covers positions when controllers are absent for short periods. To his right, we have the local or tower controller. His job primarily is to advise aircraft that they are cleared to taxi onto the runway in preparation for takeoff and that they are cleared for takeoff. He assigns priority and clearance for aircraft to land. Next seated is the clearance delivery controller. This man will read to an aircraft which is about to depart a list of clearances he may expect, as to runway to be used for takeoff, the altitude to climb to, and the route to proceed along. To his right, standing, is the ground controller. Aircraft taxiing are confronted with a complex system of pathways. From ground level, it is difficult to determine the most direct route to the terminal gate, and the ground controller makes it part of his job to save the aircraft unnecessary taxiing time and fuel consumption. Fire trucks, aerodrome police, catering vans, aerodrome maintenance crews, to name a few, all have to be given clearance by radio by the ground controller. And finally, we have the flight data controller. This man prepares the flight progress strips which will have the pertinent information concerning all departing aircraft. The control console is equipped with instruments to read out density of fog, approach light intensity control switches, telautographs for immediate weather information, and frequency monitoring speakers with associated radio equipment. Large-size wind velocity, direction, and barometric pressure indicators provide for instant readout. All clocks throughout the aviation world read the same, or Zulu time. The red button provides an emergency alerting signal. This signal alerts fire and police immediately should an accident occur. A complex interphone system exists to link all ATC air traffic control services. Here we have a time clock and a stack of flight progress strips ready to be filled as flight plans are called in from the center. Although the fire service is alerted very frequently by air traffic control to stand by, it is both fortunate and a tribute to conscientious controllers and pilots that they seldom have to deal with the real thing. When the tower controller pushes the red button, several procedures will be triggered simultaneously. A horn blows, lights go on, The doors to all truck garages open. We might just watch to see what would happen if the red button were pushed. Two-way radio is part of the equipment on each truck. All trucks will be under the ground controller's supervision as they roll out to the part of the field designated for their standby. As well as the coordination of the fire services, air traffic control has a similar liaison with the search and rescue services. Aircraft in this transition airspace are aided by controllers to make the most direct approach and descent possible to the airdrome, or aircraft that are departing to climb on course whenever it can be arranged. The volume of air traffic arriving at or departing from high-density airdromes make it necessary for approach control to be divided into sectors, which are aligned to approach and departure paths. Control of these sectors is then arranged so that control teams are assigned to different sectors and continuity of traffic movement is maintained by a sector coordinator. Area control is laid out in much the same fashion as the approach control, although, as we have already pointed out, it is very much larger, covering many thousands of square miles. This airspace is also divided into sectors and designated in this fashion. In this room, then, from which area control is provided, we have many groups of sector controllers. Here at a typical sector, we have first of all the radar controller. He is the man who in fact interprets the radar presentation on the scope in front of him. Together with the manual controller and the assistant controller who are seated alongside, he is responsible for transmitting instructions by radio, giving pilots clearances to use certain altitudes and routes of flight. Standing and behind is the sector coordinator who assures that there is a flow of vital flight data from one sector to another, and that all interested parties are kept advised. An actual radar presentation does not define the physical appearance of the terrain. The controller instead memorizes marks on the scope in relation to their geographic positions. The crossed lines indicate reporting and handoff points, while the dotted lines define particular areas. The terminal area, shown here in yellow, is marked by the dashed line. Sectors are indicated by a different line. Here we see the plan view of the low-altitude airspace northwest of Miami International Airport. Take note of Sector R4. We will be watching a controller working an aircraft through this sector later on. Air traffic control has a responsibility to serve all users of airspace, not only the air carriers, but general aviation as well. Within their administration buildings will be found the airlines' operations offices. National Airlines has a Boeing 727 which flies from Miami to Houston at approximately 12:30 each day. They designate this flight as number 185. The crew check into the operations office 1 or more hours before the departure of their flight. The captain examines the weather situation along his route and then is briefed by the dispatcher, who gives the latest information received from aircraft who have preceded him along the same route, which he will shortly be flying. If we listen in on some of this briefing, we will hear the nature of the information a captain is given.
At 28,000, 1 hour and 58 minutes, and your alternate is New Orleans. We've got a minimum of 40,000 pounds of fuel on board, and we've got a burn-off of 19,800 pounds. Your alternate fuel is 7,000, and you'll have...
From this information, the captain will file his flight plan, which in effect says, I am going from Miami to Houston along a certain route and would like to fly at a certain altitude. It is the responsibility of the officer in charge of any aircraft to file a flight plan with the Air Traffic Control Service before he can be permitted to fly in controlled airspace. In this case, the dispatcher passes the flight plan to the communications room for transmittal to the Area Control Center. This girl can either use the teletype linkage to send the flight plan directly to the Air Traffic Control Center, or else it can be filed by telephone. As soon as the flight plan is printed by the teletype at the control center, it is time-stamped to assure that delays do not occur. Data required for the control of National 185 is noted, and pertinent information is transferred to a flight progress strip. This computer processes the information to determine if there are conflictions or inaccuracies. Unfortunately, one element is missing which prevents a complete computerization of control, and that one element is time of departure. Departure time is never known until the aircraft is in fact rolling for takeoff, and only when the wheels are off the runway is the time recorded. This time, in turn, will be transmitted to all interested parties to update all pertinent flight progress strips. From information fed in and knowledge stored, the computer knows the number of flight progress strips required for the number of sectors through which National 185 will climb on his departure from Miami International. The original teletype message, which came from the airline office, is compared with the information that has been typed out by the computer. This proofreading is to be doubly sure that the operator who interpreted the message did not inject error into the proposed flight plan of National 185. The flight progress strips are then taken, cut in a machine, separated, and finally stuffed into holders. From here they are carried on a paddle and distributed manually to the sectors which will be concerned with this flight. While this is happening, National's crew have gone aboard and are preparing 185 for its flight to Houston, Texas. A long list of unforgiving items constitutes the flight checkout, and once this checkout is finished, the pilot will call the tower for flight plan clearance.
Miami clearance delivery, National 185. We have information Foxtrot. Be ready to start engines in 10 minutes. IFR to Houston.
National 185, IFR to Houston. Expect runway 9 left. Wind 060 degrees at 25. Altimeter 3021. Time 23. I'll give you clearance as soon as I get it.
By and large, flight plan clearances are ready well in advance of the time the aircraft is due to leave the gate. However, minor delays do occur infrequently, as has happened on this occasion. The data controller contacts Miami Center to get the flight plan for the clearance delivery controller.
J119er Fort Myers, direct Egmont radio beacon, flight plan route, maintain flight level 220. WK.
Sean.
303.
National 185.
National 185, go ahead.
185, cleared to Houston Airport by J119 Fort Myers. Direct Egmont radio beacon, flight plan route. Maintain flight level 220. Turn left heading 040 for vector intercept J119. Departure frequency will be 11, correction, 128.0. 12, standby 1000.
Roger, National 185 is cleared to the Houston Airport. J119 Fort Myers, direct Egmont. Flight plan route, maintain flight level 220. After departure, heading 040 for vector to J119. Squawk 1000, standby. Departure control frequency 128.0. Ground control, National 185, pushing back from gate 32. IFR to Houston.
National 185, ground control advised and ready to taxi. Runway 9 left for departure, wind is 060 degrees at 15.
Miami ground, National 185, we're under our own power. Ready to taxi?
Morton 205, stand by just a moment. National 185, clear to runway 9 left, wind 060 degrees at 15.
Roger, 185.
All phraseology is carefully planned and is given in a precise order. It is through the adherence to international procedures on phraseology that aircraft can maneuver in the airspace surrounding the Earth without encountering substantial problems in communication. This example flight, then, is being kept uncomplicated to make the units of control which it will encounter easier to follow. The controller, as a rule, is working many aircraft at one time at different altitudes, on different tracks, and with the responsibility of assuring these aircraft safe progress through his particular unit of control.
National 185, contact Miami Tower 118.3 when you reach the run up pad at 9 left.
National 185.
It is vital that aircraft acknowledge instructions to hold or taxi into position, as the case may be. Were an aircraft to presume incorrectly that he had been cleared for takeoff, he would be in danger of taxiing out in front of the landing aircraft.
National 185, hold, traffic on the final.
Roger, 185, hold.
National 185, taxi to position and hold.
Roger, 185, taxi in position and hold.
National 185, cleared for takeoff.
Roger, National 185, cleared for takeoff.
As National 185 climbs from the runway, the local controller in the tower will advise him to contact departure control. Departure control is monitoring tower frequencies and has identified National 185 on radar as it left the runway, heading 090 degrees.
National 185 Miami departure control radar contact. Upon leaving 2,000 feet, proceed direct to the Miami vortex. Report leaving 6,000.
National 185, leaving 2,000 feet, proceeding direct to the vortex.
National 185, squawk low. National 185, squawk code 1000 low, please.
Roger, National 185, squawking at 1,000 low.
National 185, what is your altitude now?
National 185, leaving 7.6.
National 185, traffic 1 o'clock, 3 miles, southeastbound, slow moving.
Negative contact.
National 185, proceed direct Egmont and flight plan route.
Direct to Egmont Key, flight plan route.
National 185, 7 miles northwest of Miami vortex.
National 185.
National 185, contact Miami Center radar now, 126.4. Good day.
Roger, 185, changing to 126.4. So long.
Usually, before a flight has cleared a given sector, the handoff to the next sector, or as in this case, from approach control to area control, is made in advance of the time when the aircraft would cross the boundary. The following communication will be between the approach controller in the terminal building calling to this low-altitude sector, or area control, designated R4. This is in Miami Center, 15 miles from approach control in the terminal building.
Go ahead.
National 185, 7 miles northwest of the Miami vortex.
National 185, radar contact.
Miami Center, National 185, leaving 12,000 for flight level 220.
National 185, squawk code 2100 and ident. Climb and maintain flight level 280. Over.
Roger, National 185, now cleared to cruise 280, squawking 2100.
National 185, roger. National 185, radar contact. National 185, request your present altitude. Over.
National 185, now leaving flight level 220.
National 185, roger. Radar handoff on National 185.
Go ahead.
National 185, 25 miles northwest, the LaBelle Vortex, climbing to flight level 280.
Radar contact National 185.
National 185, contact Miami Center on 134.905. Over.
National 185, leaving flight level 230, changing to 134.905.
National 185, roger.
The handoff of National 185, made by low altitude sector number 4, will be worked through sector 42, then in turn handed off to sector 41.
Miami Center, National 185, leaving flight level 240, climbing to flight level 280.
National 185, report reaching flight level 280.
Center, National 185, level at 280.
National 185, minus center, roger. R41 from R42, radar handoff, 10 miles southeast of St. Pete Vortex, National 185, flight level 280.
Radar contact, National 185.
National 185, contact Miami Center on 134.35.
National 185, change to Miami Center, 134.35.
And so we have National 185 being controlled by the high-altitude sector R41 from Miami Center until control is handed over to Jacksonville Center. Houston will then take control when National 185 reaches 88 degrees longitude. At Houston Airport, a reverse procedure from what we have seen will control 185 down from high altitude to low altitude through approach control and finally safely down at Houston International Airport. For the passenger, this has been a duration of about 2 bourbons on the rocks. The passenger crossing the continent, traveling onward with the same or another airline, will be in an aircraft still under the surveillance of a continuous chain of air traffic control services. One of the western pillars of continental air traffic control is Los Angeles Tower. To appreciate the domain for which this is the castle, we should make use of the aircraft to have a better view of what man has done in this 20th century to replace the covered wagon. Exactly how old air traffic control is would be hard to say. In any event, from what we see below us now, this world of aviation has come a long way. Yet by the measure of advancement in modern civilization, it has only begun. A continual evolution in the design of aerodromes struggles to accommodate a diversification of aircraft and the multitudes who use them. While we can see below us the problems of aerodrome utilization, airspace utilization is equally, if not more, complex. The challenges are continual and unpredictable. Not only is the growth in numbers of aircraft elusive, but the size, speed, and performance characteristics are so variable that air traffic procedures are constantly being adjusted to accommodate this diverse and demanding clientele. These air carriers burn expensive fuel, even as they taxi or hold before takeoff, with departure times that are exactingly competitive. Controllers must assist them to make the most efficient use of their equipment while remaining totally impartial. The objective is to go from the departure gate of one aerodrome to the arrival gate at another in the shortest, safest, and most economical way possible. This is a dynamic, exciting, and modern world in air traffic control.